Hello everyone and welcome to this course on modern application development. Now that takes care of the wireframing. In other words, it tells you how to construct the overall structure of the view. Then comes the question of how do I implement it, right? Because finally I need to be able to generate HTML. Now there are multiple ways of generating HTML. One of them, which I'm going to talk about a couple of them in a little bit more detail than others, that does not in any way mean that I am saying that these are the only ways of doing it, right? In fact, the thing that you need to keep in mind is the simplest way for a program to generate HTML is just using print statements, right? You just keep print and print out whatever should come as HTML, right? After all, if you can use it in order to output data into a file, it's perfectly legal and easy to use it to generate the HTML which is actually required for your application as well, right? On the other hand, it's painful, right? Now we are using Python for our application development. So let's think about how we might go about solving this problem, right? And the first question that I would ask is, I want to generate a heading, right? So can I, for example, write a function that given a string would basically generate the h1 tags corresponding to that heading, right, and return that to me, right? So for example, I might have something which looks like this, def h1, and it takes a string as input, okay, and all that it does is returns this plus the string plus, okay. All that I have done is taken the tags h1 and /h1 and put them on either side of the string and returned it. Why did I have to define a function for this? Because rather than having to type in the h1/h1 where there is a good chance that just while typing I'll end up making a mistake, get one of the angle brackets wrong, forget the slash and so on, instead I can now just use h1 of hello and this will return to me h1 hello /h1, right? It takes care of the starting tag, the ending tag and everything else that is required very neatly over there. I can make this function a little bit more fancy by adding on something which allows me to specify attributes for the h1, right? Some CSS attributes, right? The CSS attribute might, for example, be used in order to say, okay, use a different color for this or use a different font, okay? There could be locations where that is meaningful, but the point is, as long as I am sort of programmatically generating it using a function, I can do a lot more fancy things with it. So I am going to take an example which is this specific library called PyHTML, and what I am going to do is demonstrate this on the replit.com playground, right? So I have just created a example replit, right, a REPL, which can be used just to demonstrate what the PyHTML library is capable of. As you can see over here, let me zoom in a little bit. Right. The main thing that comes across is that I am importing PyHTML as h. You will also find another way of writing it, which is basically from PyHTML import star, right? Now I generally prefer to avoid doing that. There are locations where it makes a lot of sense, from PyHTML import star just makes it easier to write your functions after that. But there are also problems because it now brings all of those the exported names from the PyHTML module into your namespace, right, which means that now suddenly there is a function called HTML, there is a function called head and so on, which might conflict with other functions that you had already defined, okay. So to avoid that, I prefer that you just import as h and then use h.html, h.head and so on, right. It gets a little painful because you can clearly see I have h dot h dot h dot all over the place, but by choosing a single character out here, you are probably okay, it's not too bad. So what does this code actually do? What it says is I am constructing a string, right? It basically says t is equal to h.html, okay? And as you can see, this HTML starts out here on line 3 and ends out here on line 13, okay? And inside the HTML, it essentially has two components. It has actually only two components. One of them is the h.head, right, which starts on line 4 and ends on line 6, a comma, and h.body, which starts on line 7 and ends on line 12, okay. So what's actually happening over here? If you think about it, h.html is taking two arguments. It could probably even take more arguments. Essentially what it's going to do is take a list of arguments and just output each of them one by one, okay. So h.html is pretty much what it's going to do is just put the HTML tag in front, and then whatever is inside it will just be sort of sent out, okay, and then we'll put a /html at the end of the document. What is h.head going to do? It's going to be put a head and a /head and send out whatever is inside that directly. What is h.title going to do? Add a title /title and send out whatever is inside its argument. In this case, it is just text, okay. So what we can sort of imagine is that this h.title is going to put out title, test page, /title, okay. So in this way I have constructed some complex set of HTML structure out here, and what I do is I basically say print t.render, okay. So the render part of it basically says, okay, this was a set of functions, right, its t has been created as an h.html out here. When I do t.render, what it's supposed to do is go and call all these functions, okay. So let's try it, right. Okay, so now we have the output that came from the print t.render. What does it look like? Let's go take a look at it. We have this, it starts, the first line is essentially this doc type HTML. The next is HTML, and if I go down to the bottom, I find that there is a /HTML. So I can safely assume that the h.html part of it, that function, its job was to print out this doc type HTML, print the opening HTML tag and the closing HTML tag. Those are the three things that it did. Everything else inside it, what it did was it basically added two spaces of indentation and then started calling the rest of the functions inside it. The first of those was h.head, and here we have a head /head. Inside that I have a title /title, and inside that I have the actual text corresponding to the title. The nice thing out here, as you can see, is that all of it has been nicely indented by two spaces. I believe that can also be configured, right? Change the amount of indentation that you want. That's easy enough to do. And this is perfect, right? I will never forget a closing tag. If I have a title, I have a /title, guaranteed, right? If I have a div, I have a /div. So this programmatic approach of generating HTML has this nice property that basically what we are doing over here is actually generating the data in such a way that as long as this function, this t.render, this t was constructed properly, it will always generate valid HTML. There is never any question of going wrong in terms of forgetting to close a tag or using the wrong tag or anything else. All of that is done automatically by the code, okay. Now this looks very nice. There is still a question about whether it is scalable. Let's say that I need to generate an overall page. Let's say Amazon, right, is trying to generate its output page in this fashion, right, and I then wanted to go into one part of it and modify what happens in one particular block, right. Very likely if this is the style of code that I am using in order to generate the entire text, I will find that I have a problem, because I generate all of this HTML very nicely, but then I want to go in and change one particular aspect of it. It's going to be quite difficult to figure out where exactly I need to change something, okay. So this is tremendously useful, but may not be the ideal sort of solution for what we want in what we have in mind. So as you can see over here, right, with this example I basically have all of this text that we had, in fact whatever we saw in the example, and it generates this output. Now the nice thing about programmatic HTML generation is that you could do something more fancy. This is an example from the website of PyHTML. You can define a function, right, that is basically going to return table rows with table data, right, by iterating, right. So this for cell in row is essentially Python code, right. It's basically TD of cell for cell in row is what's called a list comprehension in Python, right. So essentially row is an array or a list. This is an element and that is then taken and placed within TD tags, right. And how do I get row? This is an array, but the CTX of table is now going to be an array of arrays, right. So as long as I have an array of arrays and each one of those elements comes out as a row, I can then pass that in and each of those elements of that row can then be encapsulated within TD tags, placed within this TR, and the whole thing then comes out as one nice displayed table, okay, and all of that was encapsulated into this one function that I wrote. Okay. So it's possible to generate something fancy like this by using very minimal amounts of code by using a library such as PyHTML. The problem, of course, as I said, is that let's say you need to go in and make a change in one part of the design. You will probably need to wade through a whole lot of PyHTML code and try to figure out where it is without damaging anything else. An alternative, which is preferable in general, is something called templates, right? And templates over here, there are essentially they consist of some kind of a standard template text and some way by which variable information can be brought into that text. It can be interpolated into the text. They also have some very limited means of programmability, usually to sort of iterate over loops, and there are many different examples of how you can implement templates, right. That's one of the drawbacks, right, which is that there are so many different ways of doing it that you don't know which one to choose, right. So ultimately you probably just need to pick one and go with it. For our case, since we are going to be using the Flask framework, again the question might come, why are we using Flask? It's because it's simple and relatively straightforward. It's by no means the only one, or many people would argue that it's not even the best one to use, right? But it is a good enough framework for illustrating all the concepts that we need, right? Which is why we are choosing to go with Flask. And Flask works well with this templating engine called Jinja 2, right? And that's the one that we are going to be using for our applications over here, right. So using the same REPL, we are now going to look at another example where we use the Python string template functionality, right. So what we can see over here is I am just from string importing template, okay. This is part of the standard Python library. I don't even actually need a separate module out here. What I do is I create a template, right, where I say $name is the $job of $company. Anything with dollar is now a variable that needs to be replaced with some other information. How do I get the variable information? I say t.substitute, right, and I give name, job, company and run it, right. So what happens if I run this? It actually, without any further delays, right, because after all template was part of the Python string library, it straight away printed out Tim Cook is the CEO of Apple Inc. Okay. So what has it done? It took the value for name from here, right, and put it in place of $name. It took the value of job and put it in place of $job, and it took the value of company and put it in place of $company. Okay. So this is once again in some ways is slightly better than the programmatic HTML, because you could have one chunk of text and then decide that you need to make modifications in places, but the programmatic HTML has its own benefits in other contexts. Now coming to the third way of generating output, right, which as I said is using the actual standardized templates. What we are going to do over here is use the Jinja framework, right, and Jinja is something that ties in closely with Flask, and it has complicated template functionality with a detailed application programming interface. One thing to keep in mind with something like Jinja is that it can generate any kind of output. It's not restricted to only HTML, right. So let's once again look at the REPL and try and see what could be an example of using Jinja. Okay, so let's first understand what the code exactly had, right. So from Jinja 2 I imported template, right, and then I've created my first template, which was to say T is template of hello, and you can see these double curly brackets, right. That is something that Jinja uses in order to indicate that this, whatever is within the curly brackets, close curly brackets, is something that needs to be evaluated and replaced, okay. So this something is now the name of a variable. So when I say print t.render with something equal to the value world, right, it takes that and puts it in over here, right. I see that hello world is my output, right, because it was basically hello something, but something has now been replaced by world. Now simple, straightforward, easy enough. Where it gets interesting is when we, for example, have a loop, right. So if I look at this the second template on line 5, I see that it's something which says that my favorite numbers, and now rather than having two curly brackets, I have curly bracket and percentage, right, and inside that I have a for, which looks very much like a for loop in Python or C or whatever it is, but yeah, more like Python actually, right, because it says for n in range 1, 10, right, but it's not exactly Python, because Python would then have had a colon sign over here, and it would have like indentation and various other things to think about. You don't need that over here, but the interesting thing is it allows you to run a for loop over this range, and it just basically prints out the n and finally has an end for, again something which is not there in Python. What happened when we ran that print t.render on that? It prints out the my favorite numbers part, and then it just prints the numbers 1, 2, 3, 4, 5, 6, 7, 8, 9. Right? Why did it stop at 9? Because the range of 1, 10 stops at 9, right? Exactly like in Python. So this is one way where it just sort of iterated. You could have used this in order to iterate through some other kind of variable, right? Something which is an array or a list or a dictionary. All of those could have been passed in as the argument, and it would have been able to handle those and iterate through them as needed. So that's where the power of Jinja basically comes in. The nice thing about it is it also allows a number of other ways of using it, right? You can not just construct a template like this, you can also embed templates one inside another. You can create a template for some small block, right, that needs to appear in one corner of your page, and then reuse that block across different pages. That kind of thing is generally harder to do with programmatic HTML, right, and becomes relatively easy to do when you use templates, especially a good templating engine like Jinja. One thing to keep in mind over here is that these templates can generate any output, right? Think about what happened over in the examples that we saw on the Replit. They just generated text, right? It was not really HTML. It could have been HTML, but it could also have been anything else. I could even in principle have used a Jinja template to actually generate a program by constructing some kind of a macro structure around it and maybe printing out what looks like a program after a while, right? Or I could have generated a PDF file, or even an image by directly putting data into the appropriate bitmap parts of a file and outputting them. Okay, so Jinja output, in other words, can be used for much more than just HTML generation, As far as we are concerned, we will primarily be using it for HTML.